Our next topic is going to be the OSI reference model. The OSI reference model provides us a framework so that we can understand the different elements of networking and how they work together. There are a couple of purposes with the OSI reference model to cover first, and then we'll get into exactly what it is and how it works. It's the idea of interoperability between vendors. What we want is an environment where different components from different vendors all work together. So we don't want to have to buy everything on our network from a single vendor. We don't want vendors to have a monopoly of services because they can then charge whatever they want and we're locked into that specific vendor. Whereas if instead we have a variety of components and I'm connected to a Netgear switch and that fails, I can go out and buy a Linksys switch, that makes my life easier. We prefer standardization. Usually, when we have vendors that have proprietary equipment, it may take additional training in order to work with those devices. There's usually additional costs and sometimes additional complexity. The OSI model promotes standardization. So ultimately, what we have is 7 layers of the OSI model and standards at each layer. So, if I have a layer 2 device and I built it to the standard of an OSI layer 2 device, then it will be interoperable in a standard space environment. That's great for me as a vendor because standardization sells. That doesn't mean proprietary stuff doesn't sell, but standardization really is what most network administrators are looking for. There might be times when we purchase a proprietary device or component, but for the most part, we like standardization. Each layer of this OSI model is going to give us a description of certain services based on the standard. What we're also going to see with the OSI model is an idea of encapsulation. When we talk about encapsulation, it is packaging. It's placing headers around data, or it's putting a protocol in a protocol. The best example I can offer is this. Let's say my Uncle Steve in Seattle has an anniversary, and in order to help him celebrate, I'm going to send him some champagne glasses. Technically, I could write his name on the champagne glasses and say, "Happy anniversary, Uncle Steve," and put a stamp on them and put them in the mailbox. But of course, as soon as I do that, I'll hear clink, clink, clink. So, what I'm going to do instead is wrap the champagne glasses in bubble wrap, put them in a small box, and put bubble wrap around that box. I'm going to gift wrap the box and write happy anniversary or best wishes on the box. I do want to point out that when I write best wishes Uncle Steve, that the Uncle Steve piece is an addressing element. It's not worldwide addressing, but when the package finds Steve's house, he's going to see that it's for him. So, some of what we're doing is for protection and padding, and some of it is for addressing. Ultimately, we start out with a very small payload, the champagne glasses. And as we package and add addressing and protection and all those things, by the time we're ready to pass this off to FedEx, we wind up with a much more sizable package. We continue to add. We put it in a FedEx box, we get a FedEx label, we hand it off to the FedEx carrier. That's encapsulation. It's not the same as encryption, though sometimes people make that mistake. I never encrypted the champagne glasses. I didn't magically turn them into coffee mugs. They're still champagne glasses. They're just all wrapped up. That's our goal with encapsulation. Of course, the only piece that I missed in the instructions is that if you have pets, at some point in time, I can guarantee you there will be a cat in the packing peanuts or perhaps a pug wrapped up in bubble wrap. So if you need to distract the animals, you can add those steps in here. I do want to mention no animals were harmed during the making of this video. So, this encapsulation idea is illustrated here on the right. At the top, we have 7 layers: application, down to presentation, session, transport, network, data link, and finally, physical. The idea here is data conceptually travels down through the OSI model. When I say that, what I mean is that the sending computer starts with an application layer protocol. So, application layer protocols are those protocols that drive user application. If you think about a web browser, you've got HTTP. If you think about mail, you've got POP3 or IMAP or some of those other mail protocols. So data starts at the very top of the OSI model, and as it conceptually travels down, headers are added. So you can see we start with the data alone at the application layer. But as we move down to presentation, we get a presentation header, a session header next, a transport header, then network header, data link header, all the way down to the point where we have the conversion into bits that relay electronic signal on the network. At each layer, something is added that will help the data get to where it needs to go, all the way to the destination hosts. There's formatting, there's perhaps receipt of acknowledgements, there's IP addressing, there's MAC addressing, and all these things we'll talk about as we move on. But I just want you to have this idea that at each layer, something gets added until the computer is ready to put that data out on the network. Now, I would definitely recommend that you know the OSI model top down and know it by number and by name. All people seem to need Domino's Pizza is a good little trick that a lot of folks use from the top down. All people seem to need Domino's Pizza. That will help you remember. My personal favorite from the bottom up, people don't need to see Paula Abdul. Change my mind, I'm standing by that. But at any rate, find some little trick. I do not recommend that you go out and Google mnemonic tricks for the OSI reference model. There are some things you cannot unsee, and there are people of questionable intent on the internet. That's all I'm going to say about that. And what I've probably just done is guaranteed that 2,200 people go on the internet and Google mnemonic tricks for the OSI model. But at any rate, find some trick that helps you remember it and go with that. Okay, the other thing I ask you to think about is that at each layer of the OSI model, we refer to data a little bit differently based on the headers. When data is at the application presentation session layer, we still refer to it as data, but once it comes down to the transport layer, we have a segment down to the network layer. We have a packet down to the data link layer, we have a frame, and at the physical layer, it's converted into bits. So, segment, packet, frame, bits. Sometimes you'll hear these terms used interchangeably, and that's okay. But I just want you to know that really these terms should vary based on the headers that have been added to the data. So, a packet has more headers than a segment. A frame has more headers than a packet. And so, specifically at the transport layer, there's specific transport information that's added to the header. Next, at the network layer, specific information is added. Then, at the data link layer, specific information is added. This kind of gives you an idea of the broad purpose of the OSI model. Just keep in mind it's a 7-layer model. It's designed to promote interoperability among vendors. There are standards at each of the layers, and really what it does is it helps us describe the process of encapsulation and the adding of headers so that data can get from destination to destination with the correct information.